welcome to the fourth lesson on time, speed and distance. This lesson includes miscellaneous questions related to the topic, which are very interesting. So let us move to our first slide. Two trains A and B run in opposite direction on a circular track. Train A travels at a rate of 4 pi miles per hour and train B travels at a rate of 6 pi miles per hour. The radius of the circular track is 6 pi and both trains start from point D at the same time. How long in hours will the two trains meet at point D after both the trains depart? Now, since the track is circular, therefore we are going to first determine the circumference of this track, and the circumference of a circle is equal to 2 pi r, where r is the radius of the circle and we have the radius equal to 6 pi. So the circular track measures 12 pi miles. Now let us see in how many hours will the two trains meet at point D. That is the point from where the two trains started their journey. It takes 3 hours for train A to reach point D, or in other words, to complete one round of a circular track. And it takes 2 hours for the train B to complete one round of circular track, right? Now meeting at point D means we are supposed to take the least common factor of the time of trains A and B, that is the LCM of 3 and 2, which is equal to 6. You can also take it this way, that the train A will reach point D at the 3rd, 6th, 9th and so on hours, and train B will reach point D at 2nd, 4th, 6th, 8th and so on hours. Therefore, it would take 6 hours for the two trains to meet at point D after they depart. So our answer option would be A, that is 6 hours, right? Maya and Dolly run a race between points A and B, 5 kilometers apart. Maya starts at 9 a.m. from point A at a speed of 5 kilometers per hour, reaches B and returns to point A with the same speed. Dolly starts at 9:45 a.m. from point A at a speed of 10 kilometers per hour, reaches point B and comes back to point A with the same speed. At what time do Maya and Dolly first meet each other? Now, our first step should be to see where Maya is at 9:45 a.m. If she is going at a speed of 5 kilometers per hour, this means that after 45 minutes, which is 3 by 4 of an hour, she will be at a distance of 3.5 kilometers from point A. Now, this is the time when Dolly starts from point A. There is a clue in this question, which is that the speed per hour of Maya is equal to the distance between points A and B, that is 5 kilometers. Therefore, at 10 a.m., that is after 15 minutes, Maya will reach point B and Dolly will cover a distance of 2.5 kilometers in the same time, right? The distance covered by Dolly is equal to 10 into 15 over 60, which is equal to 2.5 kilometers, right? Since Maya and Dolly are coming from opposite directions, therefore their respective speeds will be added to get relative speed, which is 15 kilometers. Now, at 10 a.m., Maya is at point B and Dolly at a distance of 2.5 kilometers from point A. The distance between points A and B is 5 kilometers. Therefore, the distance between Maya and Dolly will be 5 minus 2.5, which is equal to 2.5 kilometers. Now the time at which Dolly and Maya meet each other will be equal to the distance over relative speed, which is equal to 2.5 over 15. And to convert it into minutes, we will multiply it by 60, which is equal to 10 minutes. So Dolly and Maya will meet each other 10 minutes after 10 a.m. That is at 10:10 a.m. So our answer option will be B, right? This problem states that a trip of 900 miles would have taken 1 hour less if the average speed for the trip had been greater by 10 miles per hour. What was the average speed for the trip? Now you see in this question, after we make a table, we see that because there is no variable with either t1 or t2, therefore we cannot solve the question by variation method. So we will use the regular method for solving it, right? Now we know that t1 minus t2 is equal to 1, as it takes 1 hour less to cover a distance of 900 miles if the initial speed is increased by 10 miles per hour. If the old speed is s, then the new speed will be s plus 10. Now from the table, t1 will be equal to 900 over s and t2 will be 900 over s plus 2. Putting these values in the equation, t1 minus t2 equal to 1, and solving it, we get s equal to 90 and minus 100. Since speed cannot be negative, therefore our answer will be 90 miles per hour, that is answer choice E. Now another way of solving this question is by trying the answer options. You see, if the average speed is option A, which is 40 miles per hour, and if increased by 10 miles, it will be 50 miles per hour. And 900 is divisible by 50, but 900 is not divisible by 40. And hence it will not give us a difference of 1 hour. And same goes for all the other answer options till option D. But if we divide 900 by 90 or 100, we get a difference of 1 hour, right? So this one is quite an easy thing to do for solving questions like these. But please do not go for shortcuts unless you have perfect command over the topic. Katie passed a milestone on a highway while traveling back to her home at a constant speed of 50 miles per hour. 15 minutes later, Jack passed the same milestone traveling at a constant speed of 60 miles per hour while going in the same direction that Katie is going. If both Katie and Jack maintained their speeds and both remained on the highway, how long in minutes after Jack passed the milestone did the distance between Jack and Katie equal 10 miles? Indicate all possible answers. Now we can see that Jack's speed is greater than Katie's. Therefore, we will have two cases here. One, when Katie is 10 miles ahead of Jack, and two, when Jack is 10 miles ahead of Katie. Since both are going in the same direction, therefore, their relative speed will be equal to 60 minus 50 is equal to 10 miles per hour. Now, 15 minutes after Katie passes the milestone with the speed of 50 miles per hour, Jack passes the same milestone. So the distance between them at that point of time will be 50 into 15 over 60, which is equal to 50 over 4 or 12.5 miles. Now, as mentioned earlier, we will have two scenarios. That is, when Jack is 10 miles behind Katie, which will be 12.5 minus 10, which is equal to 2.5 miles. So the time taken for Jack and Katie to be 10 miles apart will be 2.5 over 10, which is equal to 0.25 hours. And to convert it into minutes, we will multiply it by 60 to get 15 minutes. Now, when Jack will be 10 miles ahead of Katie, Jack will be 22.5 miles from the milestone, right? So the time taken for Jack and Katie to have a distance of 10 miles between them will be 22.5 over 10 into 60, which is equal to 135 minutes. Therefore, our answer options will be B and D, that is 15 and 135 minutes respectively. A bike traveling at a constant speed takes 5 minutes longer to travel 10 miles than it would take to travel 10 miles at 60 miles per hour. At what speed in miles per hour is the bike traveling? Now this is a relatively easy question because we've got the distance and the new speed. Therefore, we can easily calculate the new time, which is equal to distance over speed, which is equal to 10 over 60 into 60, that is the number of minutes in an hour, and our new time is going to be equal to 10 minutes. Now, going by the question, it takes 5 minutes longer to travel with a constant speed which we do not know. So what we're going to do is we're going to add 5 minutes with the new time, which is equal to 15 minutes. That is the actual time taken by the bike to travel 10 miles, right? Now, to calculate the actual speed in miles per hour, we are going to divide the distance by the actual time. That is 10 divided by 15 divided by 60. We have divided 15 by 60 because we need to calculate time in hours. Therefore, we will divide 15 minutes by the total number of minutes in an hour. That is 60. So our answer option will be B, that is 40. So the actual speed at which the bike is traveling is 40 miles per hour. This is the last problem of this lesson, and it says that an aircraft flew 600 miles to a town at an average speed of 400 miles per hour and made the return trip following the same route at an average speed of 500 miles per hour. Which of the following is aircraft's approximate average speed in miles per hour for the trip? Now, this is also a very easy question because the average speed is equal to total distance over total time, and over here, as can be seen from the table, the total distance is 1200 miles. As it is a round trip, so we are going to add the two sides distance. Now, the total time is equal to 2.7 hours. So our average speed will be equal to 1200 over 2.7, which is equal to 444.444 miles per hour, which is approximately 444 miles per hour, which is option B. With this, we conclude the lessons on time, speed and distance. I hope you have learned a lot on this topic through these video tutorials. Keep watching this channel for more videos on GRE Quant. Goodbye and have a very nice day. Thank you.